Hello everyone. Welcome to the fifth tutorial for the TinyML 3600 course. Today we're going to test the TFLM installation. TFLM here stands for TensorFlow Lite Micro. This library is going to be very important for us because we're going to use functions and like instances from these libraries and going to use them to define all the machine learning like custom applications that we're going to have for this course. Okay, so let's go ahead and deploy a simple hello world algorithm where our Arduino device is going to take in random numbers and generate, like, try to learn the sign function based on some data. So we've already set that up and it's already there in the TinyML 360 library, also in the Arduino TensorFlow Lite library. So let's go ahead and open um, that example. Go to File, Examples, and go to Arduino TensorFlow Lite, and then you can open Hello World. So yeah, you're gonna have it as full screen now. So you can see now, compared to what we had initially in the Blink example, we have like a bunch of different files. And it's gonna sound and like look intimidating, but it's not, believe me, once you get the hang of it. So we have all the libraries included here. So I would also suggest you to, like, if all of this code looks a little bit intimidating, it's fine, but you should know the basic stuff of how hash include means, like including all the libraries and all of that. So we've included some primers in the calendar as well. So yeah, make sure to go through them before attempting all of this. So yeah, we have included the libraries, then we define namespace of some null pointers and some variable names of tensor arena size, defining the tensor arena size, tensor arena. We're going to go through each of them individually later on in the course. For now, just consider tensor arena as the total space that we're going to allot our model to have all the variables and the, like the operations in. So like this is the tensor arena is the total size, like the total, like a variable which has all of the weights, the biases, the operations that the model needs to do to convert an input to an output. Okay. I can also show you the total model. So this is a model that has been pre-compiled after doing the whole collab thing that you've been doing since the beginning of the course. We have this file, which is a hex dump file, which is generated after converting the TF file to the .cc file. And we put that .cc file and copy paste it here. Now let's go to Hello World again. This is the main sketch, the INO part of the Arduino sketch. We again have the familiar function of void setup. Now what do we do in void setup? We set up the initial variables. We set up the initializations and we go from there. So we have some classes that we use from the TensorFlow Lite library. Micro error reporter, which reports the error. We get the model here, G model. G model is the model, like this model, the hexdump file. And then we define all of resolver, which in total is nothing else but all the operations that our model is going to use. Okay, so yeah, there's some bunch of stuff. And then we have void loop, which is like the main part of our code and it's constantly going to iterate. So yeah, if you look closely at the code here, we define a particular X value, which is the input, which is a random number based on some inference cycle and inference count, which are some variables defined in one of these like files here. I think, yeah. So kx range and k instances per cycle, all of this is defined. So if you want to go into the math, you can go to these functions and look at it. Yeah. So all we do is we generate an X value, a random X value. The model already knows how to, it's already been trained on values to convert. Like it basically knows what the sign function is because we've already done that by feeding it the data and like training it and then getting this hexdump file. We add this X quantized value And then we invoke our interpreter, which is basically just running the model. And then we get the output in this y quantized thing. What we do with the output is we pass it through this handle output function. And this handle output function is gonna turn the LED in the same fashion as the sine wave progresses. So if you go back to the image again, so the LED is going to slightly increase in brightness and then dim again, and then increase and then dim again. So that's how we're going to tell that this Hello World experiment of ours is working. So I think this, yeah. So if you go to output handler, you can find out how we do it. It's the same thing. It's pin mode, LED output. LED is the name of the LED built-in, which is just a variable that we define. And yeah, and this is the handle output function, which was called initially. So this just, turns the brightness and like increases the brightness and then reduces it again. Let's go ahead and deploy it. One more thing that you can note is that, okay, let me just quickly set the port again. Yeah, so that just by clicking the deploy button, it first compiles the sketch and then deploys it. So you don't have to necessarily, push the verify button separately. So right now you can see that it's the same, running the same blink algorithm that we had initially. So it's like 5 seconds of on and 5 seconds of off. And then we're going to have the sine wave function where the brightness is going to increase slowly and then decrease. So yeah, now the TensorFlow Lite models and the Arduino sketches are going to increase in compilation time because the models are big and the files are like have to link a bunch of different libraries together. So yeah, it's going to take some time, but yeah, we'll get there. We're just gonna wait for some time. Yeah. So yeah, one more thing is that when you are designing your own custom models, you have this hextom file here. Be careful if you scroll to the bottom, there's a parameter called gModelLen. This thing needs to be exactly what the .cc file outputs. So you also have a utility on the calendar page where you can have, okay, yeah, so it's writing the model now. Yeah, so yeah, where you can convert any TF-Lite model to a .cc model, and then you also have this gModelLen output from there. So be careful and just like include the exact same number or the model will get the errors. So now it's deployed, and you can see that this is blinking quite frequently. One of the reasons why this is that our frequency is too high for us to notice that the wave is too fast. So we can go to our debugger things that are gonna help us a lot. Okay, so we have to connect the board again. That's out. We can go to serial plotter, and you can see we have the sine wave there. Perfect. And yeah, that's pretty much for this tutorial. See you next time.